All right, about 10 seconds. So make your choice, even if you're guessing. All right, show me your answers. Okay, A. Let's try A. Why is it A?
Because the conditions to notify the police is if there's noise and movement in the bank, or if the bank vault is open and not vault closed, which would be if vault close is set to true, if the bank is closed. If it's not true, if it's not yes, then it would be you need to notify the police of that the bank vault isn't open. And
Okay.
then heard noise and saw movement. That's you need both of those to have that. And it's just sort of like optional, so either one.
Got it. So, great. So we know that the vault closed. If it's not vault closed, that's that vault is open. And then heard noise and saw movement is what we need because it says noise and movement in the bank. So this one's close, but we need that and heard noise to be a part of the, well, I guess it's not close at all because it needs an or in between. So good. It's a little tricky just looking at what is it asking? What do these even mean? Or an and. And when we put these in parentheses, that means that whole statement has to be true compared to the or. So both of these need to be true for that whole statement to be true inside the parentheses. Okay, some kind of mystery code. Consider the code segment below. Which of the following best describes the behavior of the mystery procedure? So we're dealing with lists here. All right, maybe 30 more seconds. All right, so show me what your answer is. I see C, I see A. No, what is that? What's your answer, Jacob, Maya, Evan, Maverick, Benjamin, Gus? I think y'all are pausing and waiting for everyone else to answer. Is that A, Christopher? Is it C? All right. I see A and I see C.
Dude, I think it's because well, it cycles through each item list, and then if the item that it's looking at, or if the item it's looking at currently in the list is the word, it'll return true.
Uh-huh.
Oh, wait, no, what? Oh, yes, it'll return true, but
What do we
something doesn't
know?
make sense
Okay.
because at the end it's returning false anyways, so it would always return false when the
So let's think about it. We don't have B and we don't have D. Those people didn't choose that. Why? What's the word that you see here?
There's no, it doesn't return the index.
We don't know the location in the list of this word, so there's nothing in there that talks about the index. Remember, this is a list. So I'm going to pull up the pseudocode. Exam reference sheet. Let me just do this. All right, so what's the answer choice D or C? What's the main keyword it's doing? What's the action this program is taking? What's the first word in the answer choice on, well, I don't know, let me pull it up. What's the first choice in C? What's the first word?
Is display.
Okay, let's look at our pseudocode reference guide. How do we code a display this text? What's the code?
You do display.
Right, you just write display. Is display coded on this code at all?
No.
What are we doing instead? What's the action taken by this program?
Returning a value.
Do you remember what does return mean in a procedure?
Once the, well, it takes it and then brings it back to where the procedure is called.
Right. So if I had a mystery, if I typed in some kind of variable equals mystery, my word, the list, it's going to send me back. What is it going to send me back? A value, a Boolean, a string, a double? What's it sending back?
Well, here it's always returning a Boolean, but the Boolean
Right.
is always false.
Well, let's say the word was in the list. What would my mystery procedure return?
False. It would return false because, yes, after the for loop, it'll return false as the procedure. The return false isn't inside of an if statement saying that if you executed that.
You're saying because even though we had the return on the inside of the for loop, the last return would override it?
Yes.
All right, so okay, here is important. The return statement may appear at any point inside the procedure and causes an immediate return from the procedure back to the calling statement. So what would happen the first time the list finds that there's a word in the list? Or that our procedure mystery finds that the word was in our list? What's it going to do?
Would send back true.
And then it returns true. And then according to our guide, what happens when the first return statement is read by the code?
It ends the loop.
Right. So it's going to stop the procedure the first time it sees return. So I wanted to clarify that. It's a little confusing. So we're looking at that now. What do we think the two answer choices are that are possible now? Are we displaying or are we returning?
The only answer choice would be A.
Right. So we're returning something and we're not returning the index. We're returning a true or false, whether or not. So whether or not, that's our Boolean. So Cameron, I think Christopher, you put A. Who else put A? So this is tricky, Jacob, you say. Display, just kind of coming back to display is a technical term for pseudocode for like printing. We're used to printing in JavaScript. Pseudocode is called display. Okay, good. All right, question 6. Biologists are researching the migration patterns of birds. They have attached tracking collars to several wild birds. For each bird, the following geolocation data is collected at frequent intervals: the time, the date, the location of the bird. Which of the following questions about a group of tracked birds could be answered using only data collected from the tracking collars? This is a data question. We didn't really go over this in our class, but I figured we could probably figure some of this out because it's simply saying, what could you figure out only using the date, the time, and the location? So I'll give you about 30 seconds. This one, I think, just kind of don't think about it too much. You don't have any other information besides the time, the date, and the location of the bird. What could you determine? All right, so go ahead and show me your answer. I see B, I see C. What's your answer, Jacob? I can't see your. Oh, okay. Cool. All right. D. All right. So let's think about, we have the time, the date, and the location. What's the first question? Why can we eliminate the first answer here?
Because
would-
the callers. Oh, you can go.
We wouldn't be able to tell if birds are born.
We have no idea what's going on with their birthing process. All we know is the time, date, and location. All right. What about, do the migration patterns of the birds vary according to weather? What piece of information are we missing that we need to answer that question?
You don't have the weather.
We don't know the weather. Maybe you could figure that out using Google or something, but at the moment, we're saying only using date, time, and location. So try not to, with these data questions, what's tricky is when you go, well, I could figure that out if I had one more piece of data, if I went on my own to go find the data of the weather. So we don't know the data of the weather. And then what about answer choice D? What don't we know that the time, date, and location, we're missing something?
You don't know why they would die or even if they are.
Yeah, your bird could just not be moving on the ground. You think, is it dead? Is it alive? I don't know. It may be asleep. So this is the only one we could work on. In what month? Because I have the date and tend to travel the farthest. Did anyone struggle with this to say, well, I don't know how far they traveled? No. It's a little tricky because sometimes you think, well, I have location. Is this one piece of data, or could this be like they've tracked it over time at different locations? So B is the answer. So most of these data questions is kind of like this, determining if you can just look and see, okay, there's a bunch of extra information I don't know, so those answers I can't get. Okay, here is like a kind of a technical question around what programming language kind of does. So the program is expressed in a program language, meaning I've just typed it in my my terminal. I've typed in my code. I send it to the computer. So which of the following is true of the program? The program can also be expressed as binary code, but this increases the likelihood of errors. The program can also be expressed as binary code, which is what the program will be translated to in order to execute on the computer. The program cannot be expressed as binary code. Some parts of the program can be expressed as binary code, but most features of programming language cannot be translated to binary code. So A, B, C, or D, I'll give you about a minute right now. Look at those answers. Which one is true? All right. So show me your answer choices. What do you got? B. All right, Remby, why B?
I chose B because if it's in programming language, then it's gonna be in binary code, I think.
Okay. It is the right answer, but I just want to make sure we're a little more confident. So what is the only way computers can read information?
Binary code.
In binary, yeah. So everything actually gets distilled down into binary. So for a program to run a program, for a programming language to be run on a program, it has to be able to be expressed as binary code, which we don't have to see. We don't care. But the computers needs to, at some point, see it as a bunch of zeros and ones, because that's the only way these processes will occur inside the computer. So programming, it should be able to be expressed as binary code or else it won't work. So this is just saying some, but not all can be expressed. I think the tricky part of this question is it's this first statement. A program is expressed in a programming language. What does that mean? That seems really complex or confusing. What are they talking about?
By programming language, they're talking about different well, interfaces that humans would use to program actual computers, like JavaScript, Java, C++, or C.
Right. Like I can't type a Word document and say, do my homework or do 2 + 2 and like take a picture of it and send it to my computer and say, why didn't it work? So this is just what it's saying. It's actually a program has used the correct, programming language. That's all really it's saying. So we can express it in binary code, which will be translated in order to execute on the computer. All right, a large set of data contains information about all students in colleges across the country, across the United States. The data set contains the following information about each student. So this is just like question 6. We have the gender, we have the state that they attend college, the student's grade point average, and the student's major. Which of the following questions could be answered by analyzing only information in the data set? So we only have those 4 pieces of information. Which of the following could we decide on? All right, show me your answers. You see B, I see D, mostly B. Benjamin, Cameron, what do you think? What's the answer here?
I'm still thinking.
Are there any answer choices you could eliminate? Which ones could we eliminate, Ben? Or just one of them?
Uh,
So answer choice C talks about other countries. Do we know anything about other countries?
No.
No. What about graduation rate? Do we know how often they're? No. Okay, what about these last two? We have which college?
We don't have the specific colleges, the information about the specific colleges.
So what do we have?
We have which state in which the student attends college, the student's gender, and the student's grade point average, and the student's major.
Right, so this is kind of tricky because it talks about we have all students in college, but we don't know anything about which college they're in. We only know the state in which they attend college. So based on that, we can't ever figure out which college has the highest number of female computer science majors. We can only determine how many states have computer science as a common major, the most common major for female students. Okay, good work. Same as question 2, we have the figure below represents a network of physically linked computers labeled A through F. A line between two computers indicate that the computers can communicate directly. Any information set between two computers that are not directly connected must go through at least one other computer. So what is the minimum number of connections that must be broken or removed in the network before computer E can no longer communicate with computer F? So just don't, maybe stop and think. And you're looking for the minimum. We could do it with 4. I'm sure we could do it with 4. But what's the minimum that computer E could no longer communicate with computer F? All right, let's try it. What are your answers? All right, B. Why 2?
Because if you break the lines on either side of F, then you can't get it to E.
Okay. Is that what you're going to say too, Liam?
Yes, you can disconnect both of the lines from F, and F can no longer communicate with anything.
Yeah. So once you've isolated F all by itself, it's off the network. You only need 2 connections to disconnect that. I think what's tricky about this question is they're asking about in reference to E. How can I stop E from communicating with F? And suddenly you start maybe thinking about disconnecting E, which takes 3. But all I need to do is disconnect F, which is only 2 connections, and therefore it'll no longer be in communication with E wherever it is on the network. Okay, let's do one more question. Okay, so this was another section we didn't really cover too much in class, which is talking about the digital divide and computing in the community. So the city government is attempting to reduce the digital divide between groups, which means that there's certain groups that have higher access to technology, internet. That's the digital divide. There's certain groups that have better access to more technology than other groups in our world. Which of the following actions is most likely to be effective in reducing the digital divide? So I don't know how long we need to think about it. What do you guys think? Tell me your answers.
Well, I think B because well, A, that's really only to vote online, but that doesn't specifically mean that they'll have that internet afterwards, after the elections end. Putting all government forms on the city website, well, how is that going to help anyone who doesn't have internet in the first place? And then providing online basic computing classes for free. Once again, if you don't have internet, how can you be online? So the only one that would make sense in this context is providing free wireless internet connections at locations in low income neighborhoods, which are also more disproportionately affected by the digital divide.
Thank you. Right. So the providing the internet, because if we don't have internet, we can't even do the last two. And again, the first question, voting online is very, infrequent, once a year, maybe twice a year at most. Okay. Well, let's stop there. We've got 10 questions. I did want to ask, does anyone have like a section of, if anyone remembers what we talked about last semester, was there anything that you wanted to cover during these sessions? My plan is to cover everything, but was there something special, pseudocode, procedures, loops, lists, if statements, the robot? Was there anything that you really wanted to cover? You feel like you're really, okay, loops, yep. We'll do loops.
Yes, to add on to that, like loops and pseudocode, and also just the general functioning of procedures in pseudocode.
All right. And then who, I know I asked already, but who needs help with their create task and would like to collaborate with their fellow classmates? I know, Harrison, you said you would.
I would be open to helping people.
Okay, good. So that's the 20th of May. So it's 2 months away, 2.5 months away. And again, a lot of you you've done something, but it's still a draft. You have to finalize it. So you can work all the way up till then to finalize it. And then are we good next week if we met at 12:30? I know, Liam, you said you better at 12.
Well, I misheard it. I think it should be fine at 12:30.
12:30. Okay. That way Mr. Foster can join us, and I think we can do a little bit more one-on-one. All right, cool. Well, that's all. I just didn't want to make this kind of short. I don't want us to, drag on too long, but just get back in the swing of things. So thank you all for showing up. This has been great. It was great to see you all on camera, and have a great rest of your day.
Bye.
Okay, bye-bye.
I'm gonna see you, Mr. Guy. Have a good day.
All right, you
Mr.
too.
Guy, I have a question.
Yeah.
So I was just having a question about the create task. So the create task is just like you said, it was just finalizing our work for what we did for our performance task.
It's the same thing. Create and performance. I'm sorry, I'm using kind of a different word. The performance task is the create task. It's the same thing. So the digital portfolio where you've uploaded your code, your video, and your written responses, that just needs to be finalized by May 20th. So you have most of it already done.
So basically we can add finishing touches if we want to.
Sure, you could do whatever you need to get that ready. Yeah, it's not done. If you've, let's see. Nope.
Okay, but I'm a little bit confused. So if we already finished the performance task and we've already turned all that stuff in, do we have to?
But you've
Do we
only
have
turned
to
it. I think you've only turned it into me, right? You didn't turn it in.
Well, I turned it on. Well,
So you
I've
said
already-
you've made it final.
we've already turned it into AP class. Well, the college board, well, whatever that thing was.
Yeah, here, the digital portfolio. All right, Christopher, so you made it final. If you want, let's see, you want to do something different. I can return it.
I was just asking if we have to do, if there's any other more work that we have to do in the create task portion.
No, if you have finished it and you've submitted it, it's all done.
Oh, so we
Yeah.
don't.
No,
We
there's
don't
nothing.
have
I just see there's a lot of people with the red triangles. That means it's still a draft. So you, Remby, Isaiah have all finished it. It's all submitted. You don't have to worry about it anymore. So you're good.
Mhm.
Yeah. I'm just saying if you
Okay.
want to go back and check it and redo it, I can return it, but I think you're probably fine. It's probably fine and good. So I'm just really speaking to the people who still need to finish it. But if you're done, you don't have to worry about it. That was my goal for most people, was just to get it done. Then you don't have to worry about it at all this year, this spring. You can just focus on the exam. So you did that.
Okay. Well, thank you. So we're gonna go. So we're gonna do it. We're gonna do the same thing next week from 12:30 to 2.
Yeah. Yeah. And just kind of go through questions and just take practice questions and see how everyone's feeling.
Okay.
All right. Thanks, Christopher.
See you then.
Okay. Bye-bye.
All right.